done with momentum in the next 20 minutes or so, because I want to get to some other topics. What are my expected? Expected definitions should be what? Define momentum, which is the product of mass and velocity. Be able to define what? Impulse, which is the product of net force and the time taken for the force to act on an object. The law of conservation of linear momentum in an isolated system, the total linear momentum is conserved. And what is an isolated system? We know that what? A system where there are no external what? Forces. And we're done. Those are the four major definitions that you need to know when it comes to momentum. All right. Guys, and we know, look, just before I start looking at the question, I might not even, I'm just going to run through. When it comes to momentum, please, oh no, I forgot. How can I forget? Number 5, elastic and inelastic. And many of us normally get elastic collision and inelastic wrong. We just say a collision where kinetic energy is not conserved is 0. That's complete 0. All right, quickly, I'm going to summarize here and also mention that. Now, look, first step is to check the position of your objects, whether they are separate or together. I'm sure you know the formula, right? The main formula is to say that the sum of initial momentum is sum of what? Final. Once you get that correctly, if the objects are separate, you know what to do. M1 VI1 plus what? M2 VI2. So check if the objects are separate. If they are together, it means they have the same what? Velocity. This is what I'm going to do for you. Elastic and inelastic. What is elastic collision? A collision where both what? Momentum and kinetic energy are conserved. Please, between today and when you write, get onto the website. There are free resources that I uploaded for you that you can use. All right. There's a question here that looks so nice. I don't know how many of you did. I actually had to go look for this question. All right. This one is very straightforward. We just paraphrase again. Is that okay? We paraphrase through it. And guys, you still have a full day to run through as many questions as you can. Doing a demonstration to determine the recoil velocity of a certain type of a gun, a bullet of 5 grams. That's the first error. The first error is to work with grams, right? We divide by 1,000 to convert into what? Kilograms. Is fired from the gun of mass 5 kg. Wait. Okay, let's read through. The bullet moves horizontally at a constant velocity into a wooden block of mass 2, all right, that hangs vertically from a ceiling by means of a string. The bullet block system, already they told you it is inelastic. Once objects are together, it is what? Inelastic. The bullet block system swings to a vertical height of 6 centimeters, another wrong unit. How do you convert centimeters to meters? Divide by what? 100. 100 cents make 1 rand. All right, cents to meters. You divide by what? 100. That's what I use. Should I forget? Divided by what? 100. All right. Above the original position, ignore. Let's see what the examiner is all about here. I'm not going to calculate. Number 1, done. Number 2, suppose the original position of the wooden block is 0. Calculate the velocity of the bullet before it entered the wooden block. What are we looking for? Velocity of the bullet. Where is the bullet? So, wait. Before it entered the block. Let's see what we have. What velocities do we have? Do you have any velocity? All right. So let's go check something quickly. So here is the wooden block, right? Are you with me? Please listen now. That's the bullet. All right? And we have the gun. The bullet was in the gun. It was fired. We are looking for the velocity here. What do we do before it entered? And apparently, we do not have any velocity at all. It becomes very challenging. However, we were told that this object swings up. Okay, wait, if it swings up, you know what I then know? I know that the final velocity here of the bullet block system is 0. Now, if I use the law of conservation of mechanical energy, I think we should be able to get somewhere because we know this height. Remember, this is what? EK plus EP, mechanical energy. And I also have what? EK plus what? EP. Does that make sense to you? All right, I'm going to do a shortcut now, which I believe you should understand from grade 10. Since the final velocity is 0 here, it means the whole of this one is what? 0. Half mv squared. Since there is no height here, it means my total potential energy is what? 0. What does that tell us? It tells us that half mv squared here is equal to what? mgh at the top. I don't know if that makes sense to you. Because EP is 0, mgh, height is 0. All right, I know that, right? Now, what is this mass, guys? It is the bullet and the block. I think we have both masses. Are you with me? All right. I have that, I have that, I have that. Oh, it means I can get the velocity of the bullet block system. Does that make sense? But that is not what I am interested in. I am interested in the initial velocity of the bullet. Now I can come and say m1 vi1 plus what? m2 vi2 will be equal to the bullet block system m1 plus m2 vf. This is the most important section. It's interpretation that matters now. Do I know the mass of the bullet? Yes. Do I know the initial velocity of the bullet? No. Do I know the mass of the block? Yes. Do I know the initial velocity of the block? Yes. It was 0. Stationary. Do I know this m1 plus m2? Yes. Do I know this final velocity? There. It's a multi-step question. Automatically now, that's why it's 5 marks. I can get the velocity of the bullet before it entered. I don't know if there's any question. Those of you at home, is my analysis okay? Those of you here, are you okay with the analysis? So please, you need to analyze and check. What is it that I have? What is it that I don't have? How can I get what I don't have from what I have? All right, recoil velocity of the gun. It means we are looking for the final velocity of the gun. Okay, and we can use, let's see, can we use change in momentum to get that? No, because we do not have, do we have time? We're not given any other information, right? All right. Now check this. We're not given any other information, so it becomes a bit challenging. Recoil velocity of the gun. Wait. They were together. Are you with me? And now, separate. So it means M1 plus what? M2. This is the gun now, right? VI would be equal to what? M1 VF1 plus what? M2 VF2. Gun and the bullet. Before the bullet was released, they were both what? Stationary. I don't know if that makes sense. The bullet is in the gun, but the gun was what? Stationary. Now I think we are done. Guys, if we say this is our gun and that's the bullet, do we know the mass of the gun? Yes. Do we know the final velocity of the gun? That's what we are looking for. Do we know the velocity of the bullet? Yes. Do we know the final velocity of the bullet? That's the one we got in the previous what? Question. Your answer here should be a negative what? Answer. Why? The gun goes this way. It's a recoil. It is a recoil. All right. I think that would be what I would say on momentum. A missile here. You know, guys, the questions are basically what? The same. What I would have loved to, yeah, this is the one. I'm sure everyone did this question. Everyone did. I just love the fact that it's a simultaneous what? Equation. All right. This, in case you want to go back to it, this is from KZN. Just check KZN, either 2017 or I think it should be 2017. Is that 2017, I think. Please go and it's lovely. It's lovely. All right. It is a simultaneous because there are two things you will not know. So take note, either 2017 or 2018, one of the two. But it's a very beautiful question. Time will not allow us. I am moving on to... That was just a quick summary, right? Please get on. You've done a couple of questions. If you can practice 3 or 4 questions on momentum, you will be okay. It was just a summary on momentum. That was 12 minutes. Hold on. Just before I round up. Okay, I'm glad I'm still here. Hello. How do you check if a collision is elastic or not? How do we check if a collision is what? Elastic. What do we do? Number 1, calculate kinetic energy, total kinetic what? Energy. Before collision. Number 2, calculate final kinetic what? Energy. Compare. If the total kinetic energy initial is equal to the total kinetic energy final, what do we say? It is elastic. And if they are not equal, what does it become? EKI is not equal to what? The sum of the kinetic energy final, then it is what? Inelastic. Everybody should know that by now. And what's the formula for kinetic energy? Kinetic energy is what? Half mv squared. Please watch out for objects that have that are together. It's very, very important. All right, thank you, bro. So that was a very, very short recap on